Well, hello students, we are back and today we will learn the hydraulic press part in this chapter. Alright, so for that we need to learn the Pascal's law. We already shared a note about that as very small note where you will get a little bit idea about the Pascal's law. But now let me explain that one very nicely over here. Alright, so suppose you have a container and this is one open place from where you can put some water in it. So whenever you're putting some water in it, time by time it's getting filled. So whenever it's filled at some moment totally, then if you put any more water in it, then what will happen? You are actually pressurizing this whole system. Right now it is full of water. Now you are adding more water in it. So right now you are pressurizing this whole system, and this pressure, or I should say this force, will get distributed in all direction. How? Let me show you. You can take one example for this. Suppose you have a bottle and you are putting water in that with a nozzle. This is a pipe or nozzle, you can say, from where the water is coming to that bottle. So what happened in it? Whenever the water bottle gets full, then the pressure exerted by the extra water, is get distributed in all direction. And that is how you can say the pressure exerted by any liquid in a closed container will get exerted equally in all direction. And that is what Pascal's law. You can take any other example with that. Suppose all of you know that water balloons. What happened with that? Whenever you try to fill it up, but after some moment, when you fill it overly, what will happen? It will burst out. And why it is happening? Because you are constantly filling this one with water, and also the pressure, I should say the force in all direction, is gradually increasing with that. So at a certain moment, whenever the water balloon is not enough to keep the force, then it bursts out. So this is also another example for Pascal's law, that the liquid exert the pressure equally in all certain direction. One most common question come with it, that let we have a water balloon full of water. So now you are doing some hole in here, hole in equal places. So the water will flow with same speed in all certain direction from all those holes. So that should be the condition. Why it is happening? Due to Pascal's law, as the force of water is spreading equally in all certain directions. That is what you have to understand by this Pascal's law. Okay, so what is the basic use of that? The basic use of that is in hydraulic press or any hydraulic machine. And how that is work? I am drawing very easy principle or very easy mechanism for this hydraulic press. You can see there are two chambers. One is little bit broader, another is little bit smaller. And these two chambers are full of liquid. These are the pistons. Piston means that movable system. If you press this, it will move down. If you pull it up, it will move up. This is how it's work. So we have this piston over here. Alright. So now coming to the area, obviously the area of this one is bigger than the area of this one. So you can say that AB is greater than AS. Acha. So now I'm applying some force in here. Okay. So that is say FB. FB is the applied force in this bigger piston. What will happen? Whenever the force will get applied, it will spread that force in all certain direction. Even it will pass that force through the liquid in the other piston. So due to applied force, this piston will move down, and this piston, by channeling the applied force, will move up. And as the area is less, so the second piston, that means the smaller one, will move more up over there. We can show it by mathematically that how much force it is experiencing. Alright, so we know that pressure P is equal to F by A. Now as you can see, in this case pressure is constant. No variation of pressure is occurring. That means F is proportional to A. You can see it from here that if P is constant, that means F is proportional to A. So F1 by F2, or I should do it like this, Fb by Fs according to this diagram, then this should be equal to AB by As. So as you can see that this is the relation between the forces with the area of the piston. So from here you can say as AB is greater than AS, that means FB should be greater than FS. Simple one. So this is all about the forces and according to the piston's area. Now coming to the systems of this hydraulic machine. For the car washing, we use a platform. Whenever the car placed over there, the platform is raised up and they can wash the below of the car very easily. We can see in the petrol pump that this kind of thing. So that is also by hydraulic press. So we can see that hydraulic press, hydraulic brake and hydraulic lever, all kind of things are going to use this basic principle of hydraulic machine. Now we are moving to the atmospheric pressure. This part is coming in your exam, it is not been reduced, so you have to read it. So in this chapter we have some basic cause and effect type question. In the first one you can see we are having some plastic water bottle. So if you press it, what will happen? It will look like this after getting pressed, and in that condition, if you close the cap of that bottle, it will remain like that. Why? Because the atmospheric pressure in outward and inward in the first condition is same, because in both case, first of all the bottle is open, so in both case, that is inside of the bottle and outside of the bottle, same air is present with same pressure. But when you lock that up with that cap, now as you already press that one, very less air is inside and a pretty much vacuum is also inside, and that is why the pressure is getting decreased. So the pressure inside of the bottle is now low, but the atmospheric pressure is same in the outside, so it will press it inward. As you can see, as a result the bottle is now totally bent out. So that is the first condition or the first experiment. Same experiment you can do with this kind of method. So the next one, right now we have a plunger with that barrel. That is nothing but our holy wala pichkari we can use over here. So this is a very easy and common example to make you understand for the piston effect. So this is the lever or plunger, whatever you will say. If you push it down or if you pull it up, it is actually a piston. It is working as a piston. So suppose you have Obviously that is in the holy, you have full bucket of color. Now you put it that down inside of the water. Now what you do, you pull it up, you pull the plunger up. So whenever you are pulling the plunger up, the vacuum space is coming inside of that. The vacuum is getting created inside of that, and that is why we know that water is already experiencing the atmospheric pressure from the upward surface. Now that pressure will get distributed in all direction according to Pascal's law, and as they got vacuum over here, they will rush up to pour the pitchkari with the colored water. So this is how the water will get insert in this pitchkari, and that is the mechanism of that. Now we will discuss about what is barometer and how does it work. So in here, as you can see, we have a completely inverted glass tube inside of mercury. Why mercury? We will talk about that later. So first of all, this is completely inverted glass tube in a pot full with mercury, and also this container, or sorry, this tube have some mercury up to this level, and this part is vacuum. That means completely empty, no air, nothing is there. Achha. So we know that air is constantly giving the atmospheric pressure in this mercury, and that atmospheric pressure will get distributed in all certain direction equally, and as this part is vacuum, so due to increase of atmospheric pressure, this mercury will also get lifted up, so the mercury level will rise a little bit due to the exerted pressure. Similar thing will happen if the outer pressure get decreased. What will happen? Then the mercury level this time fall, because the pressure is now actually decreasing, so this will fall a little bit down. So by this experiment, you can actually assume the atmospheric condition, the weather condition mainly. So we have already learned that how the barometer will work and what is the use of that. Barometer is specially used for to determine the pressure of the atmosphere. We know that already. So right now we are coming to this part. Why we use mercury in the barometer? That is the most vital question. So we use mercury in the barometer because first of all it is non-sticky to that glass tube. So if it will stick to the glass tube, so it will be very difficult for us to determine the exact value of the mercury level. But as it is not going to stick, so we can clearly find the value of the mercury level. Now next, the mercury vapor is very negligible, so it don't hamper any kind of error in the level of pressure. So for this all benefit, we use mercury, and we don't use water for the opposite disadvantages, because we know that it will stick with the glass tube and not very sensitive. So instead of water, we use mercury. While you are moving in a certain height, the air pressure is getting decreased, and this is the graph by which you can show it. This is the atmospheric pressure in along y-axis, and along x-axis you have the height of from the sea level. So as you can see, it is gradually decreasing in this case. So that graph is very much important, and as you can see, this is completely giving you the idea with increase of height the atmospheric pressure will decrease. Now coming to the weather forecast. So first of all, this weather forecast condition is depending upon the atmosphere with two characteristics, that is the temperature of the present condition and the moist present in air. We know that if the temperature will increase, then the pressure of the total atmosphere will get decreased. Also, the moist or the vapor present in the air, if increased, then also the gradual decrease will happen in pressure. But we know that. But how we can apply this all characteristic to determine the weather forecast? So these are the ideas given over here. Suppose due to those change of pressure, we can observe by the barometer, we can see if a fall or sudden fall of the barometer level, then we can assume a cyclone or a big storm is coming. If the level of barometer is gradually decreases, then we can say that rain can be possible over here. So what if the level of barometer will increase quickly? Then we can say that the area is now low pressure zone while the flow of air is very high over there. And due to that, we can determine that what the weather is going to be right now. Now coming to the last one, that is altimeter. What is that? Altimeter is used to determine the height. But remember, it is a barometer. It is an aneroid barometer. So whenever the height is increased, then we know obviously the pressure will decrease, and by that mechanism in that altimeter we use to determine the height as well. So that is all about the barometer, the pressure of fluid, and the pressure of air, weather forecast, how that is related to the barometer and the pressure of air. These all things are very important. Please note it down, and if you have any doubt, you can write in the comment section. So thank you.